maybe there are more open questions. For sure there are. It's never so easy. So I guess we can spend today talking and working through the idea of Python magic numbers and how to make them work better with operating systems.
All right, so let's see where the magic number is.
Yeah, I would really like to hear some intro to it.
So,
do you happen to know why it's called magic number? Like in engineering, there's not so many things that are called using esoteric language.
I don't know. I know it comes from things like the file command. Let's see if I give it an H file, it'll tell me it's C source. If I give it a PNG file, it'll tell me it's a PNG image and so on. And traditionally that looked at like the first 4 bytes of the file and tried to find some information there. So for example, some okay, this is a PNG file. It's a 128 by 128 8-bit color image, and that's read from some header in the file. And usually the information about the type of the file will be at the beginning, and there will be something called a magic number. I don't know why it's called a magic number, but it's called that, and it says what the file, what the type of the file is. I don't know the history, but I think this is where Python's version magic number comes from. It's pretty much at the same place in the file. Hello, Miro.
Hello.
So what did you want to talk about?
How can Fedora not rebuild everything when there is a magic version bump?
Alright, so let's see where this magic is. We're looking for the import magic number. I see getText has magic number for some message archives. Import lib util magic number. That looks reasonable. I need to be in so magic number, and it's imported from Bootstrap external. And that's from the imp module, and that one's in C. And there's a PYC magic number token. So that's so I know the underscore imp module is written in C, and it apparently has a constant called PYC magic number token. So there needs to be a C string somewhere with this value, and that's usually how I find stuff in C. So import.c. C in Python, and it'll be at 4841. Here it is. So when the import module is created, some stuff happens, and then it adds the int constant pyc magic number token. So that's the C name for this thing, and it's defined in PyCore magic number. Why it is private, I don't know, because it's not exported publicly, but yeah, this is it. Okay. Is this new? There's a whole header for it now. I think it used to be part of some other header. Yeah, and this has the whole history of magic numbers, starting from Python 1.5 to the ones that had trouble. Oh, here we go. Everybody had trouble with here. And this magic number is checked somewhere, right? So it's, I think it's checked in Bootstrap external here. So there is this classify pyc function, performs basic validity checking. That's what we need. Gets the contents of the pyc file, name for, I guess, messages, exception details get passed to import error. Great. An import error is raised when the magic number is incorrect. So the pyc file has the magic number as the first 4 bytes, right? So here I guess Fedora or something would need to patch this check. And if you allow a different magic number here, yeah, you're fine. But you also want to make it safe, right? So you probably want to only load the old magic number that's, you know, being taken care of, and only loaded in PYCs that are compiled specifically for one version of the interpreter. Right?
Yeah.
That's mostly the idea.
So I was thinking, when we build Python, we would say which magic numbers we want to import. It would be a range or a list, doesn't really matter.
Mm-hmm.
And then we would also mark our pyc files as inspected, basically. Like, this is a pyc file that the Fedora Python team has deemed to be okay to be loaded, even if it has the older number that we compiled Python.
Right.
And then every time the magic number would be bumped late, like in the RC phase, we could check all the Fedora and see which packages are impacted by the actual change.
Mm-hmm.
Make an informed decision that we are not going to rebuild them all, but we are only going to rebuild the 5 packages that are actually impacted. We could also check that they are able to build, and then we would compile the new Python version saying it can load the magic version from the previous one. And it would only work for Fedora packages, not for third-party code that we can't read. That was the general idea. I don't know if it's worth it.
Right. So if you're going upstream, it probably can be specific to Fedora.
Yes, exactly.
But It can be generic in the way where you say if the PYC, I mean, so the PYC is specific for the interpreter that it's installed for, right? Because it's installed in side packages of a specific Python, and it shouldn't really, I don't think there's really a mechanism that copies it somewhere else. Yeah, so if you install it for Fedora's Python and it has this bit set, it's specific to that Python. And any other distro can do the same thing.
We would get a defined value that says it's our Python. We compile Python with number 75, and we compile PYC files with 75.
So I was thinking you use one of the bits in like the next 4 bytes are flags. So that's 4 bytes, and 2 bits of those 4 bytes are defined. So Fedora just takes one, or well, this feature just takes one more bit, and if it's set, then the PYC is marked as, you know, belonging to, in your case, Fedora's Python.
Yeah. That's we would then build all our PYC files with this flag set before we know what's going to happen, because we can't really rebuild them when it happens, because that's what we do now.
Right.
So that doesn't really solve it. So we would, for the future, mark all the Fedora's PYC files as eligible for this mechanism. And then in Python, when we build it, we will decide whether to opt in for this or not, for the previous magic number.
Right. So from the upstream point of view, it's just, you know, adding another one here and updating all the comments on the communication, and probably needs to be a pep even though it's 1 bit. And yeah, well, all the other work, as you say, would need to change. Well, I guess wheel installation would need to change, but we're in control of that, right? Mostly.
Yes. But, so I was thinking, and I was already discussing this with Carolina just a tiny bit. Currently, when there is a magic bump, it's usually because there is a crash.
Yes.
And the crash only impacts.
Well, when there's a magic number bump in like a beta or release candidate.
Yeah, I mean,
yeah.
Whether there is a late magic number bump, yeah, it's because there is either a crash or like serious data problem. You would get different results or something. It's a serious thing anyway, but it's, I would say, some construct that's not always everywhere.
Yes, otherwise it would be caught in dust, right?
It would probably be caught sooner. Yeah. So for the sake of a handful of packages, we are rebuilding everything, which is an overkill. But also, we get the additional safety. I mean, if we can't rebuild something, the old PYC files will never be loaded.
Right.
If we do it this way, and we opt in for the older PYC magic number, we explicitly say that we must rebuild everything that's impacted or it's going to crash.
Yes.
And we have the ability to pre-check this before we make the decision.
Right.
Somehow. Fedora is a moving target, so you never know if something built today, it might be built tomorrow, but generally speaking, we could try to build all the packages that are impacted, or even try to build all the packages and compare their PYC files, but that's another problem. If it doesn't build, you cannot compare it. And then we say, yes, okay, this is safe, we can do it, and we say that the magic number from the previous release is accepted when this bit is set.
Right.
And then there's another part of the problem which is more Fedora related than Python related. This is how do we set this bit only for the official Fedora packages that we can check, but don't let people build RPMs.
Yeah.
That also set it. Like, for example, when we built the bytecode, we would do if this is the official Fedora build of the official Fedora package, set the bit. And that's hard, I guess. Or
Yeah, well, can you do that?
I'll definitely need to research that. I'm not sure if we can do that. We can probably check if the build is happening in Koji, but then everybody can build anything in Koji. I don't know if we can check if the build happens from Fedora Git, because at that point when the build is running, the Git is not there anymore. So
Right.
That's going to be tricky. And if we can't do that, I'm not sure if we can even...
Yeah, then this all doesn't make sense. That's
exactly.
correct.
So
yes.
this is like a multi-plane problem, or how to define it? Multi-dimensional problem. Yeah, that's what I wanted to say. Would it make sense for upstream to even like have this bit for something that's very much Fedora specific at this point? I mean, we would not design it as Fedora specific, but it's Fedora driven. Yeah.
To give you one bit, which can be taken back at any time. Yeah, I don't think that's a problem.
Yeah, it's one bit, and probably a configure mechanism to bake in allowed magic numbers.
I would leave that to patching.
Okay, so basically we make a pep that says that this bit is reserved for redistributors purposes, and that's it.
You probably want to say what it's used for, like define the semantics in that pep. But those semantics would like not matter in whether the pep is accepted or not.
Yes, I would not propose a pep that says give us one bit of this, and we will not tell you why and what we're gonna use it for. Okay, I'll have to think about it. Thanks.
It could even be like an informational pep, which means you can change it at any time without going through approvals again.
Carolina, is this something you want to drive?
It's a very complex question, but
you don't have to answer right now. Think about it.
I'll think about it.
I'll definitely find out if you can mark Fedora packages.
That's very important. Maybe I'll just ask somebody. Let's ask AI.
AI, of course, knows more than the leading experts.
So there was also the thing when we were talking about it with Miro, that if the package doesn't build, we will never know. And we'll never know if it needs the rebuild or not. Like, we cannot compare. And that's potentially much more dangerous than the current case.
So one way to do this is rebuilding the entire package. Another way to do this is just compiling the PYC. If you can reliably map the source code to the PYC, which might not be trivial, it might be, but maybe not, then you can just compile it again and probably run it through Marshall parser.
Yeah, so if we get the already built package that contains the py files and the pycache directory with the pyc files, and we compile all, we run compile all on the content, and then run it through Marshall parser or the Rust implementation of Marshall parser, and then we see if the pyc files differ in anything that's relevant, so probably everything but the magic number, then we know we are safe, and that might be actually much faster than building the package.
Yeah, and finding the like py and pyc files that correspond to each other will probably not be that hard for most cases. Probably for enough cases that this will be faster. Yeah.
I see in my crystal ball that will design perfect solution for a problem that will never happen again.
Yes. That worries me a bit too, but you know, it happened 2 times in this cycle.
Well, maybe that's a good first question though, like whether it's worth.
Is it worth it? Yeah, that's
through pet and finding a way to mark Fedora packages that we have control over and so on. Or are we good enough with having a script that compares timestamps of the last builds and just building it all, which takes time because it drags, but the complexity of the event is not that high, I'd say.
There's of course the solution to divert the problem and build the pyc files on installation time.
Well,
distributed computing.
How would that solve this problem?
So you have the old Python installed, and when you update Python to a new version on your machine, all the pyc files that you have by RPM, installed by RPM, are recompiled during the installation.
Whoa.
And then when you install a new Python package, it does not have any bytecode in it, and it's just compiled during the installation. I have no idea how long that would take. If you have 1 gigabyte of pyc files on disk and you update Python, it might take a while.
Yeah. But you can also only do this in the emergency case, right?
I mean the bit thing or the
the rebuild all PYCs.
Yeah, so we could ship the pyc files. So in normal circumstances, they would not need to be compiled on installation time. But then if you get the older one, it would.
And then you couldn't verify the RPMs.
You can't verify. Oh, I mean, I had recently had a discussion with the RPM folks who marked the pyc files of the Python 3 RPM module as artifact, which means they are not verifiable.
Whoa.
And I asked if we should do the same for all the PYC files we have. And they said probably yes. And I put it on my mental to do and then never got back to it. But
Wait, isn't that a security risk though?
I'm not entirely sure you cannot verify it. I think you just like, you can fetch the information about it being an artifact that you shouldn't care about, something like that. But you are correct that in our scenario we want to verify the PYC files.
Yeah. Yeah. Yes, you do.
So apparently it only affects listing the files of the package. Oh, they are still listed, so I have no idea. I'll check that one. But yeah, you are correct that if we recompile PYC files on the installation time, they will have different checksums, and that might be flagged as problematic somewhere.
Yeah. It's probably not a good solution.
There's a very Hagen question, but do we even need PYC files in Fedora?
Do you even need PYC files? Well, so if you don't have PYC files, then Python will compile, like basically generate the PYC file every time a module is loaded, and then then if you're not root, it'll throw that work away and do it away next time. If you are root, then it will write the PYC file, which then isn't checked by RPM, so that's a security issue, I guess. Another security issue is the check itself, where Python will try to write to an immutable place every time it imports, which has been flagged in the past by some scanners. So yeah, going without PYC files would be a big change and a major slowdown.
Yeah, all the problems with writing could be solved by not trying to write it at all. We could make Python not.
And yeah, so you can definitely make Python not write the PYC files.
Yes. But the slowdown, do we know what kind of slowdown that is? Have anybody bothered to measure this?
Oh.
Because that's interesting. Like, if it's a major slowdown, then I am a big no-no for this. If it turns out that it's not, maybe, I don't know.
Well, I guess it depends on your use case.
Right. If you start a web server, keeps running forever.
Yeah, then it doesn't really matter. But if it's a CLI tool,
you run it in a for loop.
Yeah. Even importing with the cache is too much for some CLI tools. That's why we're getting the lazy imports pep now. And I would imagine the parser is too slow for that.
Okay, one more question from completely a utterly different space. What if the PYC files were not stored in a system location where you need root rights? What if they were stored somewhere else on the path? And if they weren't like in the current state or accepted state, they would get rewritten. Would that pose all the security risks?
Yeah, that would pose all the same security risks. You can do that. There's an environment variable that tells Python where to put all the PYC files. Of course, then it doesn't use PYC files from anywhere else, and that would probably be specific to each user or something. And it would probably be pretty confusing for users to just, not see the PYC files where they normally are on all the other systems. But that can be explained, I guess.
Alright, I gather from your answer that it's not the best one. I didn't think it is the best one. I just wanted to.
Yeah, I mean, where would you even put those? And then of course, if you uninstall something, the PYC files remain. If you update something and changes import names, the old ones also, are not cleaned up. Yeah, it's looking worse and worse. The more I think about it.
I was thinking exactly the same problem. Like if all the PYC files were stored in the standardized per user cache directory, it's an interesting idea, but you don't have garbage collection. Yeah. And then you don't want to do a random sweep of the files when Python starts. It's horrible. So you would have to have some kind of command that would clean up the files that are no longer necessary.
And also, how would you configure this?
How do you configure this?
Python has an environment variable for it, which doesn't really work with sudo, for example. So if you do sudo python or sudo dnf blah blah blah, and you have the PYC cache set to the user directory, that's not good.
No. Yeah. That's definitely interesting.
I mean, we could definitely change CPython to look at the username or something, but yeah, that would probably be more work than the flag.
Of course, there's this interesting proposal that we should only ship the PYC files. That's been raised again and again in the past. And the
What are the arguments against?
It's too much work. It's confusing. People expect the ability to hot patch their Python stuff.
And also people like seeing the source code and their tracebacks. Maybe?
Yeah, that was... I believe that was the PySource directory that was supposed to be optional. You could have it to see better traceback.
Right. So the PySource proposal is not going anywhere, right?
Yeah. Okay. I think the topic is quite exhausted. If you wanted to talk about something else as well, go ahead.
Well, should we talk about stable API extension modules?
Okay.
Now that we have Mira here.
Oh, this was a trap. You asked me to come because of the magic number, so you could talk me into stable API. Okay.
Yes.
Go ahead. I'm listening.
Well, originally we wanted to, you know, spend another year or four porting DNF's extension to stable API. So we started looking and realized it's already done.
It's already done. Well, then you can just
It's not.
pretend you're doing it.
It's not tested and it's not installed. That's the problem.
Okay.
Yeah. So there's probably some issues in it. We don't know. There's definitely packaging issues where we don't know how to make it available to all the Pythons. But it's supposed to be compiled with stable API, so it's supposed to be compatible with multiple Python versions.
So, compatible as in when the Python bindings of DNF, and I assume this is the switch generated DNF5 stuff we are
Right,
talking
yes.
about. They are already compiled that way?
Either no, I don't think they are compiled, but you can compile them that way.
But nobody does. That's the problem.
Right.
Well, considering where they are installed, there's very little benefit of doing it right now in Fedora, right?
Exactly. Yeah.
It might be slower, stuff like that. But building it that way would at least give us more testing for the one interpreter to see if there are any bugs before we ship it somehow for others.
I mean, there could definitely be bugs, but I wouldn't really expect any bugs if you compile and run on the same interpreter.
Okay. So
it's mixing them that's you know that yeah, it makes things harder to test, where you need to build on one Python and then test on all the others. I don't know if stuff is, you know, ready for that.
It's not. We don't have the machinery for that. We can script it in our respec file with some bash magic, which is what I did to RPM, and I managed to build it for CPython in Fedora ION and install it and import it. It's probably all the other way around than it should be. As I compiled it with the system Python and then copied the compiled files for the older Python. It should be the other way around, I guess.
No, you're fine. I mean, so that should work. And we probably want to encourage that more widely.
Like compile with the newest and
compile with the newest and used with the oldest, because that way, you know, we can fix things.
Wait, so when you say it should work, do you mean it's document it as a supported use case?
Yes.
Or do you mean it might actually work accidentally?
No, it's so yes, it is document it. It is meant to be documented as a supported use case.
Okay. Okay. That certainly makes things easier for testing, because we usually, the only newer Python than the stable one we have in Fedora for testing is the alpha one.
Right.
And then you get all the other problems, like it being unstable and buggy, and then you don't know if it's a problem of the stable ABI approach or of the new Python version.
Right. So yeah, this should be a supported use case. The problem with it is nobody does it that way, so we don't get too much real world testing.
Right, so if you make C build will do it, then you get all the testing in the world. Most of the stable ABI wheels are built on GitHub Actions anyway, aren't they?
Yeah. Yeah. So I guess recommending it more widely means getting CI build will to do it.
At least that's optimal. So the problematic that we have is that we don't have multiple Python stacks in Fedora really.
Right.
So we only do have them in rel. Then we could do it in appel. So what I want to do, for example, I maintain the alternative RPM bindings for appel for alternative Pythons.
Mm-hmm.
And currently I build them for each interpreter. And when I reach the appel version for rel 11, when finally the RPM stable ABI is there, I will only build them once. And then we can use appel as somebody who, like a space where we can drive this. So when packagers want to package something like that for multiple interpreters, they can build it once and ship it everywhere. For rel proper, I'm still not convinced that the main problem is the technology, the building, as it is if people don't want more packages to maintain.
Right.
And then if we give them a tool to make it easier to build them, it won't solve their concerns. Right? If I was maintaining the Python RPM bindings in rel, and somebody told me, here, this is how you build it once and then ship it for 5 different Python versions, and then you have 5 different RPM packages with that, and 5 times the quality assurance and 5 times all the surface for people to break stuff, I would probably not be impressed.
Right.
But for appel, when people want to add packages by buckets, and it might be the nice place where to integrate this, where to develop this, and when to play with it. The problem is that the projects we focus on are the ones that are in rel proper. So we can only do it one version for the system Python from rel, and second version for all the other Pythons in appel, which kind of defeats the purpose.
Right.
I'm not sure. And then there is of course the requirement to put it somewhere on the file system, and that file system location is Python version specific, so you need to put it in multiple places, package it in multiple RPMs, which makes it hard. If we could build it as a relocatable RPM, which is a feature that is like probably deprecated or at least discouraged, That would be interesting. So that we would build one RPM and could install it in different locations. But then you are doing wheels.
Yeah, you're doing wheels. So, are you familiar with the RPM package in PyPI?
Yes, yes.
Which is downloaded 7,500 times every day.
By robots.
Is this daily?
Okay,
Right.
is it a large number? Is it a small number? I think that like every package on Python index is downloaded hundreds, thousands of times a day. So
I think this is a rather large number.
okay.
Yeah. So that's a shim RPM module. So people are definitely using this. I don't know if your customers are using this.
I don't know,
But yeah, I think people are interested in using RPM bindings that are not available for their Python. I don't know if it's virtual environments or different Python versions. That's a question.
And we don't know if it's for production purposes or for like testing something that depends on this in talks with 5 different Python versions on the CI 5 times a day, and then it gets the number higher. We don't know anything, and it's like
but this is a idea that just occurred to me. Could you package the RPM wheel as something you could install into a virtual environment?
I mean, yes. Definitely, packaging it is not hard. The hard bit is making the tools aware that it's there and that it's installable.
Yeah, true.
Could we package a lot of different wheels, put them in a shared location, and then configure our pip to use it as the secondary package index? Would that be transparent to the users? Probably not. I don't know. Like, should there be many Linux RPM wheels on Python package index with all the RPM bundled in it?
That's the way, apparently.
What would it do if your version of RPM on the system was different and you tried to write something in the database? So many questions. I don't know.
Yeah.
So
I guess the shim is fine. It's not going anywhere.
yeah. So what I would really love though, and I know it's a completely different kind of forms, is that the maintainers of the RPM package, I mean like any RPM package, not the RPM package, would just produce one RPM installable package, and I could install it with any Python and use it with any Python. So that, for example, it would be installed to user lib64 Python 3.10 plus side packages, and that would be on the path for every Python that's Python 3.10 or more.
Oh,
But then you have the metadata with dist infos. I don't think they are Python version specific anymore, so that's good. You also have the bytecode caches for all the Pythons.
so that's fine.
So
So here's the question: would it be just one, or could there be multiple? So would you install it for Python 3.10 plus and have another module for Python 3.8 plus, and you would need to pick the best one?
the one that you sorted on the path highest version first.
Because you can definitely have like userlib Python ABI 3, put it on Python path everywhere and put stuff in there, and shouldn't really be a problem.
Well, my understanding is that when you build for the stable ABI, you explicitly opt in for a Python version features that are only available since a certain release.
Right.
And if you then build it with features for 3.12 only plus, and you put it to a shared location, what happens if you try importing it from 3.10?
Well, that will probably crash.
That's the problem. If it would be silently ignored or like import error, then maybe.
So in 3.14 we have the API where we you can put in the check. So yeah, for a sufficiently high Python version, you can do that. And if you want it for a lower one, we need to look at the options there. But if you're not doing it for all the packages, but only for specific modules, we can definitely find ways to do it.
Well, if it's like new stuff, we are still good, because let's talk about the RPM Python module, which is only been converted to stable ABI in a version of RPM that's not yet in a released RHEL.
Right.
So it will be available in RHEL 11 plus, and there we will have Python 3.15 probably plus. So if this is solved in the current version of Python, and it allows us to just dump all the modules in a single location and make all the Pythons available, read them from there, we are good. Except, for example, in the Python 3 RPM package, there's not only the SO file, there are also the PY files.
Right.
And then but it propagates the import error. I think it's good. It's fine. It should be fine.
Yeah, so we have PyMod ABI in 3.15, where like at the earliest point of module initialization, you basically check if things are compatible. So that's the easiest way to get the import error. For older versions, you could add a manual check.
But you have to explicitly opt in for this when you write the code of the module.
Yes.
So that
and also if you use new API, you can't even load the extension at all, and you get a weird import error, like missing symbols or something.
But is this something we could test once and like determine the compatibility? And if we wanted to do, like, if we want to provide those Python bindings and you said for the next rel and next Python, that's probably moot because we are not going to bring there the older Pythons. But if, even if in the case of I'm trying to formulate the question.
Well, I guess one way to do it is to have specific directories for 3.10 plus and 3.11 plus and 3.12 plus, and then you just put a bunch of them on Python path.
Yeah, but does it scale? Then what would the syspath look like in 10 years?
A Python path would, I mean, so what's your support window?
Yeah.
Do you support stuff that was built 20 years ago? Of course you do,
No.
but well, 50 years ago. with yearly releases, that's the length of your path, right?
Yes. Okay, I need to give medicine to my dog. Did you end in 3 minutes or?
Yeah, we end in 3 minutes anyway.
So that's fine. I'll stay with 3 minutes. It's no difference.
So thanks for coming on the stream.
Are we gonna be famous on some server?
Yes, my audience of one person definitely loved you.
Hello, subscribe to Peter.
It's mostly available as a recording if you want to, if you fail to take notes or something. All right, thanks for the chat.
Thank
See you